Hi guys, welcome to D Squared Classroom. Today I'm going to discuss some of the very basic concepts of the EKG or the electrocardiogram, which is an indication of the electrical activity in the heart. I had somebody recently ask me, well, what's the difference between heart rate and blood pressure? And the simple answer is it's electrical activity versus mechanical activity. But the way I explained it is if you took a water balloon, the amount of water that you fill the balloon with is going to dictate how much pressure is in the balloon. So the more water you put in, the more stretched and strained that balloon is going to be. But if you were to pump the balloon from the outside, that's going to dictate the sort of electrical activity. And you can do that as fast as you want. So you could pump that water balloon 80 times a minute, let out half the water, and still pump that balloon 80 times a minute. So the electrical and the mechanical activity in that way are sort of independent. Anyway, let's jump into the EKG. So EKG stands for electrocardiogram, and I'm going to spell it the German way because that's where the term EKG comes from. They spell it with a K. So EKG, but in English it would be ECG. If I draw out the typical wavelength of an EKG, we can label the different sections, P, Q, R, S, and T. P is considered a wave. QRS, that big spike, is considered the QRS complex, and then there's a T wave. There may be other waves as well, but we'll focus on the most commonly seen. Then you can look at different segments like from T to P, P to R, and S to T. If we focus in on the R wave, which is kind of the biggest spike typically on an EKG, what that represents is the depolarization of the ventricles. So essentially the electrical activity moving down the heart into the ventricles. What happens in depolarization is the charge inside the cells become more negative, and that's when you get a nice squeeze from the heart. So if the R is representative of every time the heart squeezes and we repeat it over and over, then looking at an EKG, you can measure the distance between the R's and get an idea of heart rate. That's called the R to R interval. You can actually measure the boxes on an EKG and divide it under 300. In this particular example, I could count 1, 2, 3 boxes between the R's. 300 divided by 3 would be 100 beats per minute. Focusing in on the QRS complex, that is something that we'd be interested in the timing of as well, because it's going to tell you how fast the electrical activity actually moves through the heart and therefore how functional it is. So normal would be 60 to 100 milliseconds, and anything over 120 milliseconds may indicate a problem, possibly heart failure. The other thing an EKG can tell us is whether the heart rhythm is regular or irregular. So that's the spacing between the R waves and whether it's consistent. If you have short beats and then long beats, that indicates some type of irregular heart rhythm. Another wave that you can sometimes see on an EKG is called the U wave, and that's just after the T wave. It's typically not that obvious, but sometimes you may see an abnormal U wave. For example, if it's inverted or upside down, that could indicate that the patient had an MI, which is a heart attack. Now, sometimes on an EKG, you'll notice that the R waves are upside down. That's normal because it's going to depend on the configuration of the EKG leads or the pads that you put on the patient. In this case, if you look at the wrists and ankles, you're going to measure the electrical activity between the two. Or if you're using a 12-lead EKG, then you would be placing them on very specific points on the patient's chest and abdomen, and then looking again at the difference in electrical activity between those leads, and it creates a vector. Looking at a real live EKG, I'm going to label here the R waves. And we can measure the patient's heart rate by counting the boxes. If there's 5 boxes in between, that means the heart rate is 60 beats per minute. We can also label the different sections of the EKG. So again, if you think of the letters, it's P, Q, R, S, and T. And then we can look at the regularity of the heart rhythm by looking at the distance between the R waves, which in this case looks really good. Again, notice sometimes the R wave is upside down. That depends on the configuration. Overall, this patient looks pretty healthy.